Hello class, and welcome to Math Minutes video lesson number 36, beginning on page 16 in your notebook. This is where we're going to start learning how to solve systems of inequalities. We've just been learning how to solve systems of equations. Now we're going to look at systems of inequalities. So, page 16. Systems of inequalities, solve by graphing. Solving systems of inequalities by graphing is identical to the steps to solving systems of equations with one change. Instead of the solution being the one point where two lines intersect, the solution is a set of points. The set of points are represented on the graph by shading. So here's a little example. We have two lines. They're intersecting at this point, but because they're inequalities, there's a shaded area. That means all the points in this area are solutions to the equation, everything I'm doing. So we shade this entire area. That is the solution set. So let's take a look at how this particular graph was made. So turn to the next page, 17. Steps to solving systems of inequalities by graphing. First step we do is graph the first inequality. Well, we begin with the B. We begin at the end, which is a plus 3. 1, 2, 3. It has a slope of 2, which means a 2 over 1. That means up 2 over 1, up 2 over 1. If we connect these points, that's going to give us our line. And now, okay, let me explain. Okay, we did our points, we have our slope, but we need to know whether this line is going to be solid or dotted. If you look at the example on the previous page, one of these lines is dashed, it's dotted, the other one is solid. That's the difference between an inequality being greater than or equal to. Same thing with less than. Is it less than or is it less than or equal to? When it's just these, it is a dashed or dotted line. When it's including the equals, it's a solid line. So let's just go back. I neglected to kind of put that in your notes. So let's just kind of go back and start again, talk through this. We're starting at 3. We find our slope is 2. So that's up 2 over 1, up 2 over 1. Now, when I draw this line, I have to check. Because I have to check this. Because it's equal to, that means it's going to be a solid line. If the line is there, it means I'm going to make this a solid line. So I graphed the first inequality, but now I have to shade the appropriate side of the line or the boundary. Well, how do I know if I'm going to shade down here or on this side? Well, here's where I'm going to test the middle coordinate. What is the origin? What is that middle point? That is the coordinate 0, 0. So if I go in and substitute 0 and 0 into my equation, I will be able to determine which side of the boundary I'm going to shade. So if this is y is greater than or equal to 2x, instead of y, I'm going to make it 0. Greater than or equal to 2 times 0 plus 3. I'm substituting the zeros in for the x and the y because I'm testing this point. That means this is going to be, is 0 greater than or equal to 3? Because 2 times 0 is 0. 0 plus 3 is 3. Is 0 greater than 3? No. That means This point is not a solution. That means everything on this side is not a solution. That means instead of shading this side, I'm going to shade this side. Step 3 is to graph the second inequality. So I'm going to erase this to give myself a little bit of room. This one is starting at -2. That's down here. And then it has a -1/3 slope. That means from my point, I'm going to go down 1 and then to the right 3. Down 1 and to the right 3. Now I'm going to connect these dots, but how am I going to connect them? This is simply less than. It doesn't have the equals under it. That means it's going to be a dashed line. So I'm going to connect these with dashes. Now I need to see, am I going to shade above or am I going to shade below it? Well, we're going to do the same thing we did with the first line. We're going to test that middle point, 0, 0. So in this equation, instead of y, it's going to be 0. Is 0 less than -1/3 times 0 minus 2? Well, 1/3 times 0 is 0. So is 0 less than -2? No, 0 is always greater than negative numbers. So looking at this line, this boundary, because 0, 0 is not, again, it is not true for the equation, I am not going to shade what's up here. I'm going to shade what's down here. Now, what is the solution? The solution now is everything that is true for both lines. That means it's not that area because it was only true for this boundary. It's not this area because that was true only for that boundary. So the area that it's true for both inequalities is the solution. If you look back at our page 16, you can see that's how that was done. Dotted line, solid line, shaded area where they intersect. Those were the steps of how we were able to get that graph. So we're going to practice. So now we're ready to turn to page 18 and get down to it. So we have two lines. We are going to graph them. This one starts at a +4. There's your 4. The slope is what? It's just x. When x is by itself, it's like a 1 in front of it. So this has a slope of like 1/1. So up 1/1, up 1/1. Boom, boom, boom. Just like that. Now, is it going to be solid or dotted? Because this is just greater than, it doesn't have the equals underneath it, it's going to be a dotted line or dashed, however you want to do that. Let's determine which side are we going to shade. Let's test 0. 0 is greater than 0 plus 4. Is 0 greater than 4? No. That means nothing down here will be shaded, but instead, I'm going to shade that side. Let's do our second line. Starts at +2, right there. This has a -1 slope. That means I'm going down 1 because it's negative, down to the right, down to the right. Now, so that's going to connect. Now I'm going to look again. Is it going to be solid or dotted? Well, this one's dotted also. So let's just make our dashed or dotted line. And now for this line, we have to determine, am I going to shade everything up here or am I going to shade everything down here? Let's test 0. 0 is greater than -0 plus 2. Is 0 greater than 2? Is 0 greater than 2? No. That means nothing on this side, but everything on this side. What's my solution? The area that's overlapping. So that's this area right here. That means nothing here. It's true for one line, but not both. And this part here is true for one boundary or one line, but not for both. So it's the common area right there. That's the graph of this one. Let's take a look at number 2. Starts at -2, right there. Has a 1/4 slope, which means up 1 because it's positive, and to the right 4 because it's positive. Up 1, 1, 2, 3, 4. That's our line. Am I going to make it solid or dotted? This one has the line under it. It's a greater than or equal to. So because it has the line, I'm going to make this a solid line. Now am I going to shade down here or am I going to shade up here? Let's test 0. 0 is greater than or equal to 1/4 times 0 is 0 minus 2. Is 0 greater than -2? It is. So if this is true, I could plug in this point, it would be true. I could plug in this point, it would be true. Everything up here is going to be true. So I'm going to shade that part. Now we do our second line. This one starts at a +3, 1, 2, 3, and it has a +1 slope. So that's up 1 over 1. This might start to look a little messy because we're shading and we're getting a mess. Am I going to make it a solid or dotted line? It's going to be dashed or dotted because it's just less than. So let's do that. And which side? Am I going to shade everything under here or am I going to shade everything over here? We test 0 again. 0 is less than 0 plus 3. Is 0 less than 3? Yes. This is our 0 point. This is the line. That means everything on this side of that line is true. What's the area that overlaps? It's this area right there. We would get rid of that, and we would get rid of that. Okay, right? I think that's it. Well, I know that's a lot of work, and there's a lot of little steps and a lot of little details, but again, we'll always be going over all of this in class. So do your best, good luck with your assignment, and I will see you soon.